One more apology about that. Sorry about that. So here's what CPCTC really is. It's not integral calculus. Give that a couple years before we get to that. Here's what it is. It's an acronym, just like PLP, just like PAWS, just like, all these other acronyms that you miss right now from home. We mentioned it earlier in the year. Of course, it means the C stands for corresponding. The P stands for parts, and we use the word parts to represent the sides and the angles, so you can kind of keep track of both of those. So when we talk about the corresponding parts of the congruent triangles, of two triangles we've proven are congruent, we can always say those parts, all 6 parts have to be congruent. So it's an acronym. And so instead of writing out this 6-word definition, or maybe 7-word, 8-word definition for congruent triangles, it's a quick little short acronym that we can use in proofs. This is going to be a reason used in proofs, just like definition of bisect, just like side, 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 just like any of those. It's going to be something you use in a proof to explain why certain parts are congruent. It's actually a building block for understanding trigonometry later on in your math career next year. So, what is CPCTC? Well, it's this definition of congruent triangles. It's that acronym right there. When do you use it? It's kind of a critical part. It's kind of like this chicken and the egg argument that you may have had in your science classes. I don't know. So you might do a proof, and you might prove the hypotenuse and the leg are congruent, and they have right angles. And then you might not want to be done with the proof. You might want to do something else. You might use side, angle, side to prove triangles are congruent, or maybe side, 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 or angle, angle, side. You probably know which one is missing. Angle, side, angle. So you might use one of these 5 theorems to prove triangles are congruent, and then use these 3 eggs to cook up a congruent pair of triangles, and then you want to say, hey, you know what? The other parts of the triangle are also congruent. The acute angles in this triangle that I proved are congruent to another pair of triangle, those acute angles are also congruent because they're corresponding parts of the congruent triangles. The chicken and the egg argument would be, to do this, you have to match up corresponding parts of the triangles. But the idea is you only need 3 of them to start with. When we want to talk about the other 3 parts that are left over, we use this concept of CPCTC. So it's a step you use after parts are congruent, after you've proven triangles are congruent, later on. So a proof, instead of being a 4 or 5-step proof, a proof might have extra steps at the end when we want to talk about those remaining parts. So hopefully those 2 concepts make sense. When you first do this, it's kind of a little funky, but because of how I set up the homeworks, you can see the proofs are going to be longer. If you look at the homework assignment 714, the ones that I've numbered the steps on there, you're not done. You're not finishing with congruent triangles. You're doing something more after that. And I'll show you plenty of examples on this set of notes. So I want you to look carefully at the notes you have in front of you. Hopefully you have this 714 example in front of you. That one there, a little chicken on it. And I kind of left some parts blank on your paper. You can certainly label these C, A, L, T, X, and E on your paper. And what I'd like you to try to do is finish the first 3 statements, just looking at where I put my letters. And just do this purely based on the visual, assuming for once in my life I drew something to scale. And if we were in class, I'd call on people and I'd say, hey, Daniel, TE is probably congruent to which side? And of course Daniel would say, TE corresponds to CA, those are the congruent parts. And I'd probably say, Asa, EX is probably congruent to which part? And he would say, EX is congruent to Al, and he would finish that second statement. And then this third one, do the same thing on that one. I'd call on Shay, and Shay would immediately know that TX corresponds to CL. Bingo, you've got it. Now I'd say, well, yeah, that's going to be the given in this problem. So I'm going to put those marks in the drawing. If that helps you, fire those up there. The given in this case is what's on the drawing. And you've already sort of completed that over here, and you can write given because it was given to you. What you're trying to prove, I want you to now finish that statement. You're trying to prove that E is congruent to one of the angles over here. Now, it's pretty obvious which one of these 3 angles is congruent to. E is not congruent to C, E is not congruent to L. If these 3 and these 3 are really congruent, you could take this triangle and just slide it over to the top of that one. You'd see that E and A are the ones that are congruent. And in class, I might say, why are those the ones that are congruent? It would be obvious. Those are the ones that correspond. Those are the ones that are across from the side with 1 here. Those are the ones that are in between the 3 and the 2 marks, the 3 and the 2 marks. Regardless of whether I flip this over, turn it around, it's still going to be those 2 that correspond to one another. That concept is CPCTC. So hopefully you've got these 3 congruent statements completed on here. I did them with congruent signs. Your paper might have equal signs. Either way, it's okay. But again, that was given. So I basically gave you the idea that these triangles are congruent. So your proof is really short. Try to write these 3 letters in the exact correct letter order. And hopefully it makes sense that C would come first, A would come second, and L would come last. I'd ask Asa again, Asa, what's your second favorite way to prove triangles are congruent? And of course, Asa's first way would be angle, side, angle, but his second favorite might be side, side, side. He certainly get this right for finishing that. And then at the end of this, we can look at the letter order and say, without even looking at the drawing, and say E has to be congruent to A because those are corresponding parts of the triangles I just found out were congruent. Bingo. Here's where your CPCTC comes in. Isn't it beautiful? I hope so. If you want to pause this thing, that seems kind of quick, this is a good spot to pause and just read this on your own. This is the big idea. You got 3 parts to prove the triangles are congruent. If you want to talk about the other 3 parts later on, you're going to use CPCTC as the mechanism to explain that or to do that in a proof format, in an explanation format. And it might seem kind of obvious, but it just gives us a name for that obvious idea. This is going to come up in the next part of the video, part 3, I guess. It might say part 2 when I talk about it, but this is the next part. So it may take a minute. Label, A is the apex of this drawing. W, I, M, and P, wimpy little bottom of that triangle. A couple givens on there. Give this proof a try. I think you can get it. It's going to be a few steps. You're going to want to have it fully justified. I want to say it's like 7 steps. See if you can get that in 7 steps. Good luck. At the end of this, trying to prove that this little triangle on the inside is an isosceles triangle.